Today we are going to discuss about the Vernier caliper and its use. Now the aim of our experiment is to determine the volume of solid sphere and hollow cylinder by using Vernier caliper. Now what is Vernier caliper and what is the use of the Vernier caliper, that we will see now. Now this is a Vernier caliper. This instrument is a Vernier caliper. It consists of upper jaws and lower jaws. Now in that, again, this is a fixed jaw of upper jaws and this is a fixed jaw of lower jaws. Now again it consists of the two scales. One is, this scale is a main scale and this small one is a Vernier scale. Now this main scale is given in two systems. One is in centimeter, lower scale is in centimeter and upper is in inches. Here also the Vernier scale is given in a number of divisions. Now this can move or this can slide over this main scale. Now these upper jaws and lower jaws are used. Upper jaws are used to determine the inner diameter of the object. Suppose this is a cylinder and that we can use to measure the inner diameter of this cylinder by using this Vernier caliper in this way. Now by using this we can use this upper jaws to measure the inner diameter, and lower jaws are used to measure the diameter of the sphere or outer diameter of any object. You can put this object in these two jaws and we can measure the outer diameter of the object. Now again, if you want the depth of the cylinder, then we can use this Vernier caliper in this way. Now this is placed in this strip is used to measure the depth of the cylinder in this way, and we can use the depth to measure the depth of this cylinder. Now here these are the uses of the Vernier caliper. Now the uses of the Vernier caliper is, first is to measure the outer diameter of the sphere or any object. Again it is used to inner diameter of the cylinder or inner diameter of the object, and again it is used to measure the depth of or height of the cylinder or beaker by using this Vernier caliper. Now this is these are the uses of Vernier caliper. Now for the measurement of the diameter or any parameter of the object, we must require the least count of that instrument. You know what is the least count? Least count is nothing but the smallest measurement by the instrument or minimum measurement by the instrument, and the formula for least count is given here: smallest division on the main scale of Vernier caliper divided by total number of divisions on Vernier scale. Now this is the formula for the least count. Now here in this Vernier caliper, this is the main scale. Here this is the main scale, and in this main scale the smallest division of the main scale is in between 0 and 1 there are 10 divisions, and therefore the smallest division of one or small value of one division is 1 by 10, that is 1 upon 1 centimeter upon number of divisions are 10, that 1 by 10, therefore it is equal to 0.1 centimeter is the value of one division. Now this is now here smallest division on main scale is 0.1 centimeter. Then total number of divisions on Vernier scale. Total number of divisions on Vernier scale. This is the Vernier scale, and here there are 10 divisions on the Vernier scale, and therefore we have to write here total number of divisions on Vernier scale, capital N is equal to 10. Then the formula, according to the formula of least count, smallest division on main scale of Vernier caliper, that is S, is equal to 0.1 upon total number of divisions are 10, and therefore it is equal to 0.1 0.01 centimeter. This is the least count of vernier caliper. The meaning of this is that the least count of vernier caliper is 0.01 centimeter, means this we can use the vernier caliper up to the least measurement 0.01 centimeter, or it is equal. Now up to this smallest measurement we can use this vernier caliper. Now again there is one factor, that is zero error. How to find the zero error in the vernier caliper? Now zero error may be 0, negative or positive. First, depending on the position of the main scale, zero error may be 0, negative or positive. Now here, if the position of the main scale of 0 is exactly coincide with the first division of the vernier, then there is no error in the instrument, means it is in proper setting for the measurement. Now second is negative error. Negative error means what? If the first division of the vernier is 0 of the main scale is just behind the first division of the vernier, then it is a negative error. Then how many divisions it behind? Then that number of divisions are measured as a negative error. That zero error is equal to the number of divisions multiplied by least count. If there are 9 divisions behind, then multiplied by least count, that is 0.01, then zero error of that instrument is 0.09 centimeter. Now this much amount of this zero error we must have to add in our experiment. Then third type is the positive zero error. Positive zero error means now 0 or the first division of the vernier is away, means go away from this 0 of the main scale, then that is positive error. Now if it is 7 divisions away from this main scale, then multiplied by least count, then we get 0.07 centimeter. Minus 0.07 centimeter, it means we must have to subtract this much amount of this zero error, positive error, from our total reading. Now before measurement we must have to see this zero error. If it is zero error is 0, then that instrument is properly set and we may take the readings. But if it has a positive or negative errors, then we have to consider for the measurement or for the accurate measurement. Now we measure the diameter of the sphere. Now if this diameter, if we have to measure the diameter of the sphere, then we must have to put this sphere in the lower jaws, in between these two lower jaws tightly, and see the readings of the main scale and vernier scale. Now here main scale is first division of the vernier is near to the main scale, that is 1.8. Here 1.8, 1.5, and after 1.5 there are 3 divisions, means 1.8 is the main scale reading. Then right here the 1.8 is the main scale reading. Then in between these 10 divisions of the vernier, which line is exactly coincided with the main scale, that we have to find. Then if we see the line which is completely coincided from the first line, then it is up to 5th division is exactly coincided with the main scale, and therefore the vernier reading is a 5th division. That is, here we have to write here 5. Then vernier scale reading is what? Number of divisions of vernier multiplied by least count, means 5 into 0.01 is the least count, and it is equal to 0.05 centimeter is the vernier scale. Now what is the total reading? Total reading is equal to main scale reading plus vernier scale reading. Now it is equal to what? 1.8 plus 0.05, and it is equal to 1.85 centimeter is the total reading of total reading. Now, what is the corrected reading? Now, here corrected reading in this instrument of the Vernier caliper, there is no error, means no positive or no negative error. There is a zero error, and zero error is the zero division, and therefore corrected reading T plus Z is equal to 0, because number of divisions is 0 multiplied by least count. Then we have to add here in the total reading T plus Z, that is equal to 1.85 centimeter again. That is 1.85 plus 0 centimeter, it is equal to 1.85 centimeter. Now this is the first reading. Now for the to obtain the correct reading, we have to take the number of readings. Again we take the 2 or 3 readings for this sphere. Now we put this sphere in this way now, and again take the main scale reading. Now here if we see the main scale reading here, the 1.8 again. Now second reading is 1.8. Now find the Vernier scale reading, that is which division is exactly coincided with the main scale, that we have to find. Now I think it is 6th division. Now here 6th division multiplied by least count for 6, then we get 0.06, that is the Vernier reading. Now add this Vernier reading in the main scale reading, then we get 1.86 centimeter. There is no error in the instrument, therefore again we get the same reading, that is 1.86. Now this is second reading. For the third reading, change the position of this sphere in this way, and again measure the main scale and Vernier scale reading. Now here the main scale reading is here 1.9. Then right here 1.9 is the main scale reading, and which number of line is exactly coincided, that we have to find here. Now I think it is second division. Now second division is coincided, then Vernier reading is multiplied by Vernier divisions to, then we get 0.02. Then add this Vernier reading in the main scale reading, then we get 1.92 centimeter. Then again here we get the three readings, 1.85, 1.86 and 1.92. Then take the average, 1.86, 1.85 and 1.92. Now addition of these three, 7 plus 6, 13 plus 16 and this 10, that's 26, 2, 5, this total divided by 3, then we get 1.87 and 6 again here. Now for the significant figure we get here, we can write it 1.88 centimeter. Now this is the average diameter. Then right here 1.88 centimeter. This is the average diameter of the sphere. In this way we can measure the diameter of the sphere. Now second object is a cylinder. Now here we have to measure the dimension as the inner diameter of the cylinder. Now second object is a cylinder. Now for this cylinder we have to measure the inner diameter of the cylinder. For the measurement of inner diameter of the cylinder, we have to use the upper jaws or ears of this Vernier caliper and put these upper jaws in this way in the cylinder, okay, and take the reading, main scale and Vernier scale reading. Now here main scale reading is first division of the Vernier is near to the main scale of 3.7 centimeter. Now this is 3.5 and after that there are two divisions, then 3.7 centimeter. Here we have to write the 3.7 as a main scale reading. Now again in these 10 divisions of the Vernier, which line is exactly coincided, that we have to find. Now I think it is fifth line is coincided. Now right here fifth division of the Vernier multiplied to this fifth division of the Vernier by least count 0.01, 0.01, then we get the reading as a 0.05. Now add this Vernier reading in the main scale reading, that is 3.7, then we get 3.7 plus 0.05, that is equal to 3.75. There is no error in this instrument, therefore we get the same reading as a corrected reading, 3.75. Now in this way we can take the another position for this cylinder and again measure the reading. If the cylinder is uniform in inner diameter, then we must have to get the same reading. Now here we see here 3.8 is the main scale reading. Now what is the vernier reading, that we will see now. In between these 10 divisions, there is second division is coincided with the main scale. Now second is the vernier reading. Multiplied to this vernier scale reading by a least count, that is 0.01, then we get 0.02, that is the vernier reading. Add this vernier reading in the main scale reading, then we get 3.82. There is no error in the instrument, therefore 0 error is 0. We get the same reading as the total reading, that is 3.82. Now for the third position of the cylinder, now take the main scale reading here again. Main scale reading, that first division of the vernier is near to the 3.8 centimeter of the main scale. Then which number of line is coincided of the vernier to the main scale? I think it is the second division, again here second division, then multiply to the vernier reading by least count, that is we get the 0.02. Add this vernier scale reading in the main scale reading in 3.8, then we get 3.82. then there is no error in the instrument and therefore we get the same reading of the total reading, that is 3.82. Now take the mean of these three, then we get mean diameter. Average inner diameter is the addition of these three readings, and that is 3.796 centimeter, and for significant figures it is 3.80 centimeter. Now write here 3.80 centimeter. Average reading of the inner diameter is 3.80 centimeter. Now this is the dimension, that is inner diameter of the cylinder. Now third object is same as a cylinder, and we have to measure the depth or the height of this cylinder. And to measure the height of the cylinder, we have to use this vernier caliper in this way. This strip, tail-like strip of this vernier is touched to the bottom of this bottom of the cylinder, and see again here the main scale reading of this instrument is 4.6 centimeter. Main scale reading is 4.6 centimeter. Now the vernier reading, which line is exactly coincided, that we have to see. Second line is coincided. Now second scale division is 2, multiply to this second division by the least count, then we get 0.02. This is the vernier scale reading. Add this vernier scale reading in the main scale reading, then we get the total reading as 4.62. Again for the second observation, we get the reading as a 4.6, again main scale reading. Vernier reading in between these 10 divisions, which line is exactly coincided, that is fourth line is coincided. Then multiply to this vernier scale division by the least count, 0.01, then we get 0.04. This is the vernier scale reading. Add this vernier scale reading in the main scale reading 4.6, then we get 4.64. This is the total reading. There is no error, therefore we get the same reading as a total reading corrected for zero error, that is 4.62 and 4.64. And again for the third reading, we take then another position for the cylinder and measure again here the depth, that is again we get the main scale reading as a 4.6. First division of the vernier is going near to the 4.6 of the main scale, that is main scale reading. Now which number line is exactly coincided, that we see now here. Again there is a fourth line coincided, therefore vernier division is fourth. Multiply to this vernier scale division by least count 0.01, then we get 0.04. This is the vernier scale reading, and this vernier scale reading is added in the main scale reading 4.6. Then we get the 4.64 is the total reading, and add the zero error. There is no zero error in the of the instrument, therefore same reading of the total reading we get as a corrected for zero error, that is 4.64. Then take the average of this, we get the 4.63 figure is 4.63 centimeter is the depth, average depth of this cylinder. Now by using these readings we can use we use for the calculation. Then the radius of the sphere, diameter of the diameter divided by 2, we get the diameter as 1.88 centimeter of the sphere, divided by it by 2, then we get the 0.94 centimeter is the radius of this sphere. Now this is the value of r, and substitute this value of r in the volume of the sphere, 4 by 3 pi r cube, therefore 4 by 3 into 3.14 as a value of pi, value of r is 0.94, then 0.94 raised to 3, make the calculation here, and then we get the volume of the sphere. For third of calculation, radius of the cylinder, r is equal to d by 2, inner diameter of the cylinder is 3.80, therefore radius is equal to what, 3.80 divided by 2, and we get it is equal to 1.9 centimeter is the inner diameter, inner radius of the cylinder. And to calculate the volume of the cylinder, substitute the value of these r in this formula, then pi r square h, pi is the 3.14, value of inner radius is 1.9, its square multiplied by height of the cylinder that we measure, that is 4.63, and make the calculation of this, then we get the volume of the cylinder. Now in this way we can use this vernier caliper to measure the volume of the sphere by measuring the radius by use of vernier caliper and volume of the cylinder. Now write these results of this volume of the sphere here and volume of the cylinder is here. Now you are given the precautions of this experiment. Hold the object tightly between the jaws. Do not press the jaws too hard. Then second precaution is that take observations for diameter at different positions of the object. Now here we take the 3 positions for every dimension. Eye should be exactly perpendicular to the vernier scale and while observing the readings. These are the precautions when we measure these dimensions. Now these are the additional questions for the homeworks that you can make.